Hi guys, welcome to my channel Shiva's Tech Up. In this series of Java tutorials, today we will be looking at operators in Java. Okay, so this is the agenda for this particular session. So first we will be looking at what actually is an operator. Then we will try to understand what are the different types of operators. And under the different group of operators, we do have multiple operator types. We will also be understanding each and every one of those operator type. Then finally at the end of this video, we will also be looking into different operators with an example program. So first let us try to understand what actually is an operator. So it is used to perform operations on variables and values. So variables and values, in the sense you can directly perform arithmetic operator or bitwise operator or complement operator, any type of operator directly on the values, or you can assign those values to a variable and you can perform the operations on those variables. So that is the meaning of this first point. And also we can select the operator type based on the operation we need to perform. So for example, we want to perform any arithmetic operation like plus, minus. So according to our requirement, we need to select a proper operator type. Okay. So these are the various operators that are present in Java, various categories. So first category is arithmetic operators. Second category is assignment operator. Third category is comparison operator. Fourth category is logical operator. And the fifth category is bitwise operator. Okay, so these are the various operator types that are present in Java. Okay, so first let us look into arithmetic operators. So as the name itself indicates, arithmetic operators are basically used to perform arithmetic or mathematical operations. Okay, so these are some of the examples of arithmetic operators. So addition. Addition is nothing but it sums two values and this is the symbol which we are going to use. Plus is the symbol. Subtraction, which performs the subtraction of two variables. Multiplication, which multiplies two values. Division, which performs the division of first value with the second value. Modulus, it returns the remainder whenever you divide the first value with the second value. And increment operator, which is denoted by plus plus, it adds value 1 to the existing value that is present in x. Similarly, decrement operator. Decrement operator is exactly the opposite to the increment operator. It deducts the value 1 from whatever value you have in x. So this is about arithmetic operators. Okay, so let us try to understand the next category of operators, that is assignment operators. Okay, so basically assignment operators are basically used to assign some value to a variable, or you can also perform some operations using these assignment operators. So let us try to understand each and every one of those assignment operators. So first operator is equal to. Okay, so this is how you will be using it. X equal to 5. It means like you are assigning a value 5 to a variable called as x. Now, plus equal to operator. Plus equal to operator, it is denoted by this. You can also write it this way. It is equivalent to x equal to x plus 3. So, for example, x value is 5. Okay, let us consider x value is 5. Then x plus equal to 3 is equal to x equal to 5 plus 3, which is equal to 8. So, that is how you need to understand. Now next operator is x minus equal to. Okay, x minus equal to, in the sense you will be deducting the value 3 from the variable x. Whatever value you have in x, you will be deducting the value 3, right? So similarly multiplication. Okay, so whenever you are writing x into equal to 3, it means like x equal to x into 3. It is equal to x equal to x into 3. It means, for example, if you consider x value is 5, then the value of x will be x equal to 5 into 3, which is 15. That is the meaning of this into equal to operator. Then the next type of operator is dividend operator, which is equal to x divide equal to 3. Okay, it means x equal to x divided by 3. For example, let us consider the same example. 5 divided by 3, you will be getting 1, right? 3 into 1 is 3 and the remainder is 2, right? Whenever you divide 5 with 3. Now let us consider the modulus equal to, or you can call it as percentage equal to. it returns you with the remainder. Okay, so whenever you divide 5 with 3, okay, so the remainder will be 2, right? So that will be the output result of this particular operation. Then let us also look into and equal to in the coming slides. So these operations, so whatever you are seeing, all these operations normally you perform on the binary equivalent of a particular decimal number. Okay, so let me explain you with an example what is the binary equivalent of a decimal number. For example, x equal to 5. This is the decimal representation of a number. Now, if you want the same value 5 in binary representation, then you need to write it as 0101. Okay, so it means like it follows 8421 pattern, right? So if you consider this as 8, this as 4, this as 2, this as 1, so 4 plus 1 is equal to 5. So this is the binary equivalent of a decimal number 5. Okay, so whenever you are performing these operations which I marked over here, okay, so initially this value x should be converted into binary, then you will be performing this operation. So in the coming slides, let us also look into how we are going to perform this AND operation or operation. This is exclusive OR. This is shifting to the right shift operator, left shift operator. Okay, so that is the meaning of these things. And also here we have a description for each and every operator type. Okay, so next we'll be looking into comparison operators. So basically comparison operator, as the name itself indicates, it is used to compare two variables or two values, right? So the first comparison operator is double equal to, which stands for x equal to y. So it is not an assignment operator, but it is a comparison operator. Okay, so let me write it down. The difference between single equal to and double equal to, x equal to 5, it means like the value 5 is assigned to x double equal to 5, it means you are comparing whether the value of x is equal to 5. There is a lot of difference between single equal to and double equal to. This is assignment, this is comparison. Got it, guys? Okay, so let us look into the next. So this is exactly the opposite. Here you are comparing if both are equal. Here you are comparing if they are not equal. Okay, if x is not equal to y, then you are going to perform some operation. Okay, in that way you will be comparing and doing some operations. Okay, then the next type of operator is greater than. You are going to check if x is greater than y. Similarly, less than. You are going to check if x is less than y. Okay, so this is x greater than or equal to y. So if x is greater than y or x is equal to y, then you can proceed to the next step. So that is how you will be comparing using greater than or equal to. Then next comparison operator is x less than or equal to. Okay, so these are the various comparison operators which are present in Java. Okay, so now let us look into the logical operators. So logical operators, as the name itself indicates, it is used to check a logical condition. If that condition is being satisfied or if it is true, then you will be performing the required operation. If it is false, then you will be performing its corresponding operation. Okay, so let us try to understand. So these are the three operators that are present, logical operators that are present in Java. So the first logical operator is logical AND, okay, which stands if both the statements are true, then it will be true. Okay. Similarly, this logical OR, if any one of the statement is true, then that operation will be performed. Okay. So this is logical NOT. Okay. So first it will be comparing the condition that is present in this bracket. If that is true, then it will return false. If it is false, then it will return true. It is exactly opposite of this logical AND. This is logical NOT. Okay. So for example, if you write it as not equal to x less than 5, pipe symbol x less than 10, it is logical or not. It is exactly reverse to or operation. Okay. So that is how you need to understand this logical operators. Next, we will be looking at bitwise operators. So in the earlier slide, we were looking at some of the bitwise operators which can only be performed on the So these are some of the operations, right? So these are some of the operations that can be performed only on the bitwise, bits and bytes, right? So let us look at those different types of operators with an examples. Okay, so these are the various bitwise operators that are present. So the first operator is bitwise AND. Okay, so this is the symbol which you use for bitwise AND, and this is how you will be writing the syntax. First variable AND operation, second variable. Okay, so let us also try to understand with an example in the coming slides how this can be performed. But for now, let us try to understand what are the different bitwise operators that are present. So the next bitwise operator is bitwise exclusive OR, which is represented by cap symbol. Okay, so variable 1, cap symbol, variable 2. So it performs exclusive OR operation. Then we will be looking at inclusive OR, right? So it is denoted by single vertical line, which stands for variable 1, vertical line, variable 2. So it does the inclusive OR operation of two variables. Then we will perform the bitwise complement. So this is one more bitwise operator. It is exactly the opposite. For example, after conversion of a decimal value to the binary, if the bit is 1, then it will be replaced to 0. Complement is exactly the opposite. If the bit is 0, it will be replaced with 1. Okay, so that is how you will be performing the complement operator, and this can be performed in on one variable. Okay, so bitwise left shift. So this is the operator that is used to shift the bits to the left. Okay, so this is the value, this is the initial value. Okay, so this is the number of bits you have to shift, whether to the left or to the right. So this is the right shift, bitwise right shift. Similarly, this is the first variable, and this is the number of bits which you have to shift to the right or left. Okay, so that is how you need to understand. So let us try to understand each and every one of the bitwise AND operator. Okay, so as I said, it is denoted by ampersand, and the condition is it returns 1 if both the bits are 1, else it returns 0. Okay, so this is important to understand. Okay, so now let us try to understand. Okay, 0 and 0. Okay, so according to the definition, it returns 1 if both the bits are 1. Right, here both bits are 0, so it has written 0. Here one bit is 0, one bit is 1. Okay, it has written 0. Here the first bit is 1 and the second bit is 0, it returns 0. Here both bits are 1, so it has written 1. Okay, so let us try to understand by writing it down. So for example, x value is 0011 according to that particular table. Y equal to 0101, right? So let us try to write x ampersand y. Okay, so let us try to understand how this is being done, right? 0011. So the equivalent decimal is 3 since it follows 8421 pattern. This equivalent is 5. Okay, now 3 and 5. So according to this operation, you already got the result over here, which is 0001. Okay, so let me write it down 0001, which means 1. Okay, so whenever you are going to perform x and y operation for x value 3 and y value 5, the output result will be 1. Okay, so that is how we will be performing the bitwise AND operator. Now let us look into inclusive OR. Okay, so this is important. Understanding this definition is important. So definitely it is being uh, represented by pipe symbol. You can also pronounce it as pipe or just by vertical line. Okay, it returns 1 if either of the bit is 1, else it returns 0. Okay, so it means in simple language, any one of the bit should be 1, then the output will be 1, else it will be 0. So let us try to understand this. Okay, so here both bits are 0. Okay, so since it is written 0, here one of the bit is 1, right? So here one of the bit is 1, so it has written 1. Here the first bit is 1. So since it is written 1, here both bits are 1. Okay, so it has written 1. So that is how you will be doing the bitwise inclusive OR. So let us write it down to check the decimal equivalent of the result 0011, which is the same 3, y equal to 0101, which is equivalent to 5, then x pipe y or x inclusive or y, we got is 0111, which is according to the 8421 format, it will be 7. Okay, so if you perform x or y, x inclusive or y operation with x value 3 and y value 5, the result will be 7. Okay, now let us try to understand bitwise exclusive OR. So the difference between inclusive OR and exclusive OR is, here it checks if either of the digits in x and y is 1. Okay, then it will return 1. But here it strictly checks that only one of x and y should be 1. If both are 1, then also it will return 0. So let us try to understand. So here at least one, oh sorry, only one bit should be 1 out of this x and y. So here both are zeros. So it will return 0. In this particular example, only 1 is 1. Okay, since x is 0, it will return 1. In this case, x is 1 and y is 0, so it will return 1. Here both are 1s. So according to the definition, it only one of the bits should be 1. Okay, other bit should be 0. Here both are 1s, so it will return 0. So that is the difference between bitwise inclusive OR and exclusive OR. In inclusive OR, this part was 1. Okay, in exclusive OR, this is 0, since there is a condition that only one of the two bits should be 1. Okay, so that is the difference. Okay, so let me write it down. The same thing, 0011, which is equivalent to 3, y equal to 0101, which is equivalent to 5, then x exclusive OR, which is denoted by cap symbol. Okay, let me find it out. X cap y equal to 0110. According to 8421 format, it will be equal to 6. So this is how you need to understand bitwise exclusive OR. So let us try to understand bitwise complement. So complement, as the name itself indicates, it is pronounced as tilde operator. You can also call it as tilde, and this is the symbol. It returns the inverse or complement of a bit. So inverse complement in binary is nothing but whenever there is a 0, it will be 1. Tilde of 0 will be 1. Whenever there is a 1, tilde of 1 will be 0. Okay, so and also there is a formula. So for example, let me make you understand with an example. For example, 0101. Okay, complement of x equal to 1010, right, which is equivalent to 10, right? So this will be the expectation, correct? But the what system returns is it returns the 2's complement of this particular number, 2's complement of this particular result. So 2's complement, in order to find it out, there is a formula, right? The formula is minus n plus 1. So n plus 1 in the sense the result whatever you have got, so it will be minus 11. Okay, n is nothing but the result what you got after performing the inverse of x. Okay, so this is how the bitwise complement is being calculated. Okay, so let us look into shift operators, like shift operator, bitwise right shift and left shift operators. So as I said in the previous slide, so it is used to shift the number of bits either to the right or left. So this is being represented by the arrow. So where it is pointed, so this arrow is pointed to the right, right? So that is why we call it as bitwise right shift operator. Okay, so since this is pointed to the left, so this arrow mark is pointed to the left, right? So that is why we call it as bitwise left shift operator. So okay, so let us also try to understand this left shift and right shift operator with along with a programming example. Okay, so let's try to understand different operators along with a programming example. So I already have my code written in various Java files for each and every operator type. So first let us start with the basic definition of an operator. So if you see over here, so we do have two variables, that is int a equal to 10 and b equal to 20, right? So here we are performing some operation a plus b, okay, which is the sum operator, which comes under arithmetic operators, right? So what it prints is it should print 30 since we are going to perform the sum of three variables, sorry, two variables, okay, run as Java application. Okay, so the sum of two numbers is 30. So it is working as expected. Now let us look into the arithmetic operator example. So okay, so here I am going to take two variables a and b with a value as 10 and b value as 20. Okay, so here we are performing different operators and let us try to understand the output. Okay, so first let me execute this. Then I will make you understand if there is any issue. Okay, so now let us try to understand it side by side. So the first system.out.println statement is a plus b. It means 10 plus 20, 30 is printed. Okay, which is expected. Okay, so now the next statement which you are doing is b minus a. B minus a is nothing but 20 minus 10, which is 10. Okay, which is correct. Then you are performing multiplication operation on of a and b, which is 10 into 20 or 20 into 10, which is 200. Okay, then you are going to perform b divided by a. It means 20 divided by 10, right? So when you do 20 divided by 10, 2 you will be getting whenever you perform the division operation. So this is modulus operation, right? So whenever you are dividing the first number by second number, whatever remainder you get, that will be printed. In this case, 20 divided by 10. So the remainder will be 0. Okay. Now let us try to understand this increment and decrement operators. As I said, according to the definition, it will be adding a value 1 to the existing value that is present in the variable. So here we are taking b, right? So b is 20. So if you add 1 to this b, it will be 21. So which is as expected. Now this is decrement operator, which reduces the value by 1. Okay, so a is 10. Whenever you are reducing a value by 1, it will be 9. Okay, now this is a combination. So this is one good example of doing multiple operations on the two variables. Okay, so here let us try to understand how we are getting 30, right? So first what you need to do is you need to decrement the value of a by 1. So here a is 10, right? So when you decrement the value of 10 by 1, it will be 9, right? In this place you are incrementing the value of b by 1. So it means 20 is the value that is present in b. Whenever you increment, it will be 21. So the total value is 30. So that is what is printed over here. Okay, so got it, guys? So this is how you will be performing different arithmetic operations. Okay, so let us try to understand the assignment operator. Okay, so for example, x equal to 10. Okay, so as I said in the previous slide, x plus equal to 5 is equal to x equal to x plus 5, right? So x equal to x plus 5. So x value is 10, 10 plus 5. The first value should be 15. Okay, if you see the first value, it is 15. Got it? Now x equal to x minus 5. You can also write x minus equal to 5 as x equal to x minus 5. Okay, so it means 10 minus 5. The second value will be 5. Okay. Oh, sorry. Yeah, I got it. So the first value, the x value changed to 15, right? Because we are assigning, we are doing some operation and we are assigning the value to x, right? Now, in this case, the x value becomes 15, right? So 15 minus 5 is 10. Okay. Let me mark it over here, 10. Okay. Now, x value is 10, right? Now, you need to multiply. Okay. So let me write it down here. So after performing the previous operation, x value became 10. x equal to 10. Now, if you are performing x equal to x into 5, what will be the output? 10 into 5, it will be equal to 15. So that is what is printed. Okay, so if you see the third value, 50 is printed. Okay, now, now the x value is 50, right? So at each and every stage, let us write down the x value. Then you are going to perform x division equal to 5. It means like x equal to x divided by 5, which is 50 divided by 5, which will be 10, right? So let us try to get that value. Okay, so after 50, 10 is printed, right? Okay, so as I said, modulus operator, what it does is it returns. So the x value is 10, right? X modulus equal to 5, which is equal to x modulus 5. Okay, which is equal to 10 modulus 5, right? So 10 modulus 5, in the sense you will be getting remainder as 0. Okay, so that is what is printed. Okay, so after performing all these operations, the x value finally became as 0. Now let us try to do the AND operator, OR operator, exclusive OR operator, bitwise shift right and shift left. Okay, and also let us try to understand. So since x value is 0, run as Java application. Okay, so let us try to perform AND operation. If both are ones, it is 1, else it is 0, correct? So first let me write the x value. X value is 4 zeros. Okay, now x AND equal to 5, which is 0, 0, 0, 0. So let us write the binary equivalent of 5, 0, 1, 0, 1. Okay, it will be 0. Because both are not ones, right? 0, 0, it will be 0. 0, 1, it will be 0. 0, 0, it will be again 0. 0 and 1, it will be 0. Okay, so the output will be printed as 0. Okay, so next, let us try to do the OR operation. Okay, OR operation. So here x value became 0, right? At this place, after performing this operation, x equal to 0. Now let us try to perform OR operation. X equal to 0, right? So it will be 4 zeros. And OR operation. Okay, x or 5, which will be 0, 0, 0, 0 and 0, 1, 0, 1. Okay. So if you perform OR operation, at least 1 should be 1, right? So 0, 0, it will be 0. 0, 1, it will be 1. 0, 0, it will be 0. Again 0, 1, it will be 1, which is again equal to 5. So that is what is printed. Okay. Run as Java application. Okay. So since X exclusive OR, okay, as I said in the previous slide, it will strictly check if either of the bit is 0. So what it is doing is it will directly print it as 0. Okay. So now since x value is 0, no matter if you shift left, right, 2, 3, because all the bits are zeros, it will again output to 0. Okay. So just add it, remove it. Simple. Okay. Now if you want to perform the right shift, right? So right shift, just add two zeros, remove these zeros. Again it will be 0. Okay. So this is how you will be performing the different assignment operators in Java. Okay. So now let us try. Okay. So let us try to understand the comparison operators. Okay. So let me run it and try to understand. Okay. So x equal to 10 and y equal to 20, right? So system.out.println x double equal to y. It is checking if x is equal to y. Okay. Is it equal to y? It is not equal to y. So that is why it has printed false. Now it is checking exactly the opposite. If x not equal to y, okay, not equal to y in the sense if it is not equal to y, then it will return true. So since they are not equal, it has returned true, right? So now next operation which we are performing is x greater than y, right? So x greater than y in the sense x is 10, y is 20, which is less. X is less than y, right? So that is why it has returned false. Now it is checking x less than y, right? So since x is less than y, it has returned true. Okay. Similarly, x less than or equal to x greater than or equal to. So this is how you will be performing the different operations in Java. Okay, so these are the various categories of operators that are present in Java. That's it for this video, guys. Don't forget to like, subscribe to my channel Shiva's Tech Hub, and get notified to the future updates. And also don't forget to share it on various social media platforms. Thank you.